Hi there, this is Jacob Nash, and in this video, I will be talking about rational functions. These are actually not, they're some of the lesser important functions that you would want to know in calculus, but we would want to refresh on this a little bit. In a rational function, both the numerator and the denominator should be polynomials. So, that being said, usually they are what appears to be a fraction. So if I just had an example here, maybe I would say this. This is one of your classic types of examples of what one of these would look like. The domain of these are usually, not always, but usually not all real numbers. Now, that's a mistake that I probably made in the pre-calculus videos, saying that it is not all real numbers, because there are a few rare examples where it could be. And I already said that if the denominator happened to be x squared plus 1, then actually the domain could potentially be all real numbers, because x squared, the way that you can find the domain is you have to set each argument equal to 0, so meaning each part of it pretty much. So you can find out what things would make the denominator 0. Why? Because if it's 0, we know that is not a value in the domain, because this goes back to the first video that we said, so I don't really need to reiterate it anymore. But if you make the denominator 0, that's not good. That means that it's not a value that's in the domain. That's why usually they're not. The domain of these are not all real numbers, because usually you can make something equal to 0. For example, here, x is not 2, x is not -1, because either of those values plugging in for x would make this whole thing 0. So basically, there can be limiting behaviors that we're going to talk more about later, but you might remember the holes and vertical and horizontal asymptotes, they are common with these. Not only that, you need to take note of things that can cancel out, because that also means that there is a limiting behavior. So that's really all I'm going to say at this point about this, but you just need to remember these basics. And when these are graphed, they oftentimes look like this, but not always. But that's usually, they look something like that.